guys, welcome to Pre-Algebra for Friday, November 2nd. We're doing this by video today because I can't be up at co-op. I've got a college visit with one of my children today, so while you are watching this, if in fact you are actually watching this on Friday, I'll be involved in seminars of my own down around Waxahachie. So, let's go ahead and pray. Father God, I thank you for your goodness to us. Lord, I thank you for the just unbelievable advances in technology that there are, the things that you have allowed us to discover about the world that you've created and the way that you've designed things so that I can record a teaching lesson at home. I can convert that to something that makes sense to be uploaded onto the internet, and my kids in my class can watch the video performance. Actually, I guess it's not even a video. Watch the digital performance, Father, of their class, whether they're riding a car, looking on their iPad, or whether they're in a library, or whether they're at home watching over the internet. So, Father, I thank you for the things that are just so amazing to us that you've allowed us to discover of just a little piece of who you are, but it's so tiny in comparison to just how awesome you are. God, I thank you that you love us and that you know us and that you are helping us to be diligent and to be disciplined, to learn those things that you have us to learn while we're in school. Be with us today, be with my kids until I see them again next week. I thank you, Father, in Jesus' name. Okay, where do otters come from? They come from outer space, of course. And here's another one that's just even worse than that. What happened to the wooden car with the wooden wheels and the wooden engine? Well, that car just wouldn't go. So, I'm hopeful that perhaps this video that I'm doing of our class time, it may not be the full length of the class, because those videos are out there for the homework that you're going to have to do, but I wanted to at least be able to tell you what your homework is. I want to do a brief fire hose, like I always do in class on Friday, of what your material is. Some of you, I know, aren't watching the videos because you really don't need them. Some of you, I think, aren't watching the videos and you need them anyway, so at least if you watch this one, you'll get a little bit of an introduction to the material that we're going to be covering. First off, I want to say, obviously, since we're not in class right now, you can't hand in your homework. Your homework that was due for this week, for Friday, November 2nd, was section 4.1, 4.2, 4.3, and 4.4. Also, if you had not turned in chapter 3, you needed to have completed that as well. Obviously, you can't hand it in, so next week when we're back in class, which will be November the 9th, make sure you have the homework that you've already completed, as well as the homework that will be new and assigned this week. What we're going to go over in class today is section 4.5, section 4.6, and the final section, which is 4.7. What you'll need to do is do all of that homework, do the review, and then you're also going to have chapter 4, which will be necessary for you to complete. I'll have links to that material and a link to chapter 4 on your ARC website. So make sure that you go there, download the test, and print it out. You're going to have to bring that into class on Friday, November the 2nd. Now, I am scheduling our help class. If you look at your assignment calendar, says that November 5th we have a help class from 9 to 10:15. Once again, it's out of my home. I realize it's a distance for y'all to come. Don't come if you don't need to, but realize that I'm providing this to you guys free of charge. I'm welcoming you to come out. I'll work with you and help you clear up things that you might be having difficulty with. Since we have a test coming up, I'll go over a part of the things that are on the test. So if that's something that's important to you, I would really appreciate it if you would shoot me a text and let me know that you're planning on coming. Okay? let's see what else. Okay, next week we're going to check our notebooks. If you remember, we're supposed to do a notebook check in the first period, the first class of each month. Obviously, I can't check your notebooks. Sorry, you don't all get 100 just because it's the first of the month and I'm not there. Go ahead and make sure that you have your notebooks, everything organized. You've got your tests, you've got your quizzes, you've got your homework put in there, you have note pages. If you don't remember what your notebook should look like, make sure you look at that sheet that I gave you that says notebook requirements. I'll go in and make sure that that page is available on the art class page for you to download there as well if you don't know it. So let's go ahead and go back, begin with section 4.5, which is multiplying integers. And first very quick review of how we subtract integers. Integers are positive numbers, negative numbers, and 0. And if you're just subtracting positive numbers, you guys know that 4 minus 3 is just equal to 1. But you also know that subtraction is not commutative, means that order matters. So if we turn it around and we say 3 minus 4, that's not going to give us a positive 1, is it? Now, if this had been addition, 3 plus 4 would be equal to 7. 4 plus 3 is equal to 7. 3 plus 4 is also equal to 7. Addition is commutative. You have the same answer regardless of the order in which the addends appear. However, remember that subtraction is not commutative, which means the order is important. 4 minus 3 is 1. 3 minus 4 is a negative 1. And you'll remember that we talked about how to do this in class last week. We also have the videos that show you how to subtract integers. And the technical description of what you do is you take the absolute value of both of these numbers here, the numbers that you're subtracting. The absolute value of 3 is 3, the absolute value of 4 is 4, and you're going to subtract their absolute values. 4 minus 3 is 1. Remember, absolute value is the distance from 0 on the number line, so distance is always the same. If we have our number line right here, we have a 0, we have 1, and we have negative 1. The distance is the same if you're going in the negative direction to a negative 1, or in the positive direction to a positive 1, because you're simply moving 1 unit. So remember, absolute value is positive. What you do when you're subtracting integers, where you're subtracting a larger number from a smaller number, what they're telling you to do is find the absolute value of each of these numbers here. One is the minuend, one's the subtrahend. Don't worry about that. You subtract their absolute values as if you were doing a normal subtraction problem. And then because you're working with integers, which are signed numbers, you have to say, okay, is this supposed to be a positive 1 or a negative 1? So negative 1, because what we do is we use the sign of the integer that has the larger absolute value. Absolute value of a negative 4 is greater than the absolute value of a positive 3. So what it actually looks like is you take the bigger number, you subtract the smaller number from the bigger number, and then you go ahead and use the sign of the bigger number. Technically not correct to say bigger number, but in our minds, that's what you're thinking. So that's what you've been doing with subtraction. Now we have to decide what in the world are we going to do when we're multiplying together signed numbers. And what I'm going to do is just going to show you how it works. I'm going to give you a rule and a pattern to memorize. if you multiply two positive numbers together, your answer is always positive. You multiply two negatives together, your answer is always negative. I'm sorry, your answer is always positive. If you multiply negative times positive, your answer is negative. If you multiply positive times negative, your answer is going to be negative. This is something I just want you to memorize. What is it? What are these things called that you multiply together? These are factors. If both of your factors are positive, your answer, remember what this is called? This is called the product. Your product is also going to be positive. If both of your factors are negative, they're going to be positive. You can almost think of, it's sort of dumb, but you almost think of two negative signs having an accident. You know, they run into each other and they make a positive. If you have two negatives multiplying, you get a positive. If you add together two negative numbers, it's a negative. See what's important, that you learn the rules? If the signs are the same, the answer is positive. And the answer is positive. If you have opposite signs, the answer is negative. Always true. Remember that when you multiply, multiplication is commutative. You get the same answer no matter what order the factors are in. So it doesn't matter if you have positive and negative factors. If you have opposite signs, your answer is always going to be negative. And you have this same thing that you're going to see in division in just a minute. But let's go ahead and do a couple of examples from section, I may have called this 4.5. This is actually section 4.6. And I said this was actually section 4.6. It's not. I'm getting confused. I've already recorded for you all of section 4.5. I'm still going to record 4.6 and 4.7 to you, but what I'm doing now is going back and giving you a fire hose picture of what we did with section 4.5. Let's say that we have 4 times the negative 7. What's that going to be equal to? It's a negative 28. Why is it a negative 28? Because you have opposite signs. Positive times negative. What about negative 2 times 0? This is a good one. Looks like we have opposite signs, but we don't. There's no such thing as a negative 0. You remember a long time ago we said that if you, it's the zero property of multiplication. Anything that you multiply by 0, no matter how big it is or how tiny it is, if you multiply it by 0, you're always going to get 0 for the answer. So 0 is neither negative nor positive, so it's not like we're saying negative 2 times a positive 0. No, it's just negative 2 times 0. This is a special case. But if you have 3 times 6, obviously that's 18. Negative 3 times a negative 2 is not a positive 18, is it? Negative 3 times a negative 2 is what? It's a positive 6. Because when the signs are the same, whether they're both positive or they're both negative, the answer is always positive. You just have to have that memorized. So is there a shortcut here? What happens if we have more than one pair of factors? What if we have negative 3 times negative 2 times negative 2. How do we know what to do? Is there a rule? It says if you have the signs that are the same, when you multiply them together it's positive. Signs that are the opposite, you multiply them together and it's negative. Well, we have all of the signs are the same, but how many numbers can you multiply together at once? Only 2. Negative 3 times a negative 2, the signs are the same, so that makes this a positive 6, doesn't it? Now we have a positive 6 times a negative 2, which gives us a negative 12 for the answer. So when we say that if the signs are all the same, your answer is positive, we're only talking about 2 signs at a time. Both positive, both negative. And the reason for that is you can only multiply 2 numbers together at once. You don't go 3 times 2 times 2 is 12. You can only, now no matter how fast you do it, you're still multiplying 2 factors together by themselves to begin with. So we have 3 negative factors, we get a negative answer. What happens if we have 4 negative factors? Negative 3, negative 2, negative 2, negative 2. Can only multiply 2 together. Negative 3 times negative 2 is 6 times negative 2 times negative 2. 6 times a negative 2, negative 12 times a negative 2. Negative 12 times negative 2 is a positive 24, because when you multiply same signed factors together, they have like signs. Doesn't matter if you're multiplying negatives together or positives, you get a positive answer. So what I want you to see here is this difference. Look at that weird face. There's the smile, there's the eyes. I guess those are all of the wrinkles on his forehead. The only factors that I used here are negative factors. One time the product is negative, one time the product is positive. What I want you to see is that if you have an odd number of negative factors, your product is odd. If you have an even number of negative factors, even number, I'm sure, hoping all of this is showing, even number of negatives, product is positive. The reason for that is for every pair of negatives that you multiply together, remember they're having this rec. 2 negatives make a positive when you're multiplying. 2 negative factors always make a positive, which means that each pair of negative factors will convert to positives. So that's why even numbers of negatives, our product is always going to be positive. Okay? So let's go ahead and move on now to section 4.6. Section 4.6 is talking about dividing integers, or what do you do when you divide signed numbers. Just going to go ahead and do our short little cheat sheet again here. We can go through and say, okay, look at this pattern, go ahead and figure out what's going on. Since I'm not interacting with you now, since we don't have class 5 days a week, I'm just going to tell you what this is. quotient of two positives is positive. The quotient of two negatives is also positive. But the quotient of a negative quotient of one negative, one positive integer is negative. Okay, so what have I just said here? Well, first off, we're back to this vocabulary again, remember? What is a quotient? A quotient is the answer to a division problem. 16 divided by -4 is 4. This is the quotient, is not a negative, not 4, it's -4. This is a quotient. Quotient is the answer to a division problem. This says if you're taking the quotient of the answer of two integers in a division problem, one is positive, one is negative, the quotient is going to be negative. Obviously, if you take 16, positive 16 divided by 4, that quotient there, the solution, is positive. And this is saying, okay, if you take the quotient of two negative integers, that quotient is going to be positive. So let's go ahead and see why. How do you check your division problem? Remember, you go through this, well, -4 times -4. What you have here, you have dividend, divisor, quotient. The way you check is your quotient times your divisor has to equal the dividend. In other words, if you multiply together these two outside numbers, you have to get the inside number. That's how you check a division problem. So if I have the quotient of one negative and one positive, there's a negative and a positive. According to my pattern up here, it says this has to be negative. How can we verify that? Well, we check it. -4 times -4. What does our multiplication rule tell us? It tells us the product of two negatives is always positive. We've got a positive 16, so this one works. So that makes sense. And that's supposed to be a check. Doesn't look like it. So that one's correct. We already know that 16 divided by 4 is 4. There's no check there. Now, I have a -16 divided by a -4, and what my rule says is that if I'm going to find the quotient of two negative integers, that answer has to be positive. Well, is that true? Well, 4 times a -4, go back to section 4.5, it tells us that the product of differently signed integers is always negative. Product of a positive and a negative factor is negative. The product of a negative and a positive factor is negative. So there's nothing difficult about finding the quotient of integers, which are signed numbers, as long as you remember what a quotient is, and as long as you realize the rules for quotients are the same as for products. The quotient of two like-signed integers, whether they're positive or negative, is going to be positive. The quotient, or the answer to a division problem, of oppositely signed integers is always going to be negative. So let's look at this and see what happens. A couple of brief examples. negative 30 divided by, whoops, when they do those raised little negative signs, this is how your book would say negative 30 divided by a negative 6. They raise that negative sign up at the top. If that's what you're accustomed to doing, go ahead and do it. I never learned it that way. It's very scattered, messy looking to my brain, so I simply enclose the negative number inside a set of parentheses. Whichever works best for you is fine. Quotient is the solution to a division problem. They're asking us to do a division problem. 30 divided by 6 is 5. Okay? The signs are the same. The quotient is positive. Okay, what you're actually doing once again here is you're dividing the absolute values of these numbers, because you might not know how to divide negative 30 and a negative 6, but you know how to divide 30 by 6. 30 divided by 6 is 5. How do we know what sign to use? We use the same sign up here. Negative 30 divided by negative 6. Okay, I said we use the same sign. If the signs of the two numbers that we're dividing are the same, whether they're both negative or they're both positive, your answer is going to be positive. Now we have 36 divided by a negative 6. Ignore the signs and do the division as normal. 36 divided by 6. Now, how do we tell what sign we're going to use? If the signs are the same, your quotient is positive. Are the signs the same here? No, they're not. We have one negative sign, we have one positive sign. When the signs of the numbers that are being divided are not the same, your quotient is negative. You simply have to just have that rule memorized. Let's say that we have this problem here. Negative 24 divided by negative 3 divided by negative 2. Division is the same as multiplication, which is the same as addition, which is the same as subtraction. You can only work with two numbers at one time. We have repeated division here. Our order of operations says begin and work the division in order from left to right. So first, we're dividing 24, negative 24, by a negative 3. Just disconnect, do not consider the negative signs right now. Just say, what's 24 divided by 3? Well, it's 8. But now you have to come back and make sure that you put the correct sign in. We're dividing negative 24 and a negative 8. Those signs are the same, so the quotient here is going to be positive. Now we have a positive 8 divided by a negative 2. Ignore the sign for the moment, and you have 8 divided by 2 is 4. But is it positive or negative? You go back and you look at the numbers that are being divided. If you have one negative and one positive, your quotient, which is the solution to a division problem, your quotient is negative. How can we check this? Negative 4 times a negative 2. Well, our rule tells us, our rule for multiplying together signed numbers tells us that negative times negative is positive. So we have a positive 8. Now we have a positive 8 times a negative 3. We know that 8 times 3 is 24 because the signs of these two numbers are opposites. The sign of our quotient, the sign of our product, negative 3 times positive 8, they're opposite, so it's going to be negative. Okay. Now that check there probably made sense to some of you, didn't make sense to others of you. Don't worry, because I just sort of worked the problem backwards. But this just illustrates that with division and with multiplication of signed numbers, when the relevant integers, whether you have the two factors or whether you have the two integers that are being divided, if they have the same signs, whether that be positive or negative, your quotient or your product is going to be positive. However, if the signs are different, then your quotient, the answer to a division problem, is going to be negative, just as the product is also going to be negative. So I'm going to go ahead and pause this for a second, stop this for a second, and see how much time I have left. Okay, let's go ahead and see if we can finish up with section 4.7, solving integer equations, multiplication, and division. And we're just going to continue on with solving equations as you know how to do them. You've been able to solve equations that look like this very simply. We don't care that 4x is equal to 16. What we want to do is figure out what 1x and only 1x is equal to. And we say that we're going to isolate the variable. And we did that by looking at what operation was performed on the variable. Here this says 4 times x. So we've multiplied x. We use the inverse operation to multiplication, which is division, to undo and get back to just x by itself. 4 times x, we're going to divide both sides of the equation by 4. Because the inverse of multiplication is division. Cancel common factors. X is equal to 4. Similarly, you did the same thing when you had x divided by 4 is equal to 16. What's happened to the variable here? It's being divided. The inverse of division is multiplication. So if it's divided by 4, you're going to multiply both sides of that equation by 4. Your 4's cancel. You have x is equal to 16 times 4, which is 64. The only difference that we have now is that what we're going to be working on in this section is we are having equations to solve where we're dealing with integers, which means that we're dealing with positively and negatively signed numbers. Example number 1 says solve and check negative 4n is equal to 68. Negative 4n is equal to 68. If this were just positive 4n is equal to 68, you would simply divide both sides of the equation by what? You would divide it by a positive 4. Well, instead of multiplying by a positive 4, we've multiplied by a negative 4. So what you need to do is divide both sides of that equation by a negative 4. Any number divided by itself, as long as you have the same numerator and the same denominator, is equal to 1. They're common factors. So you have n is equal to 68 divided by 4. Now that answer is going to be 17, but is it going to be a positive or a negative? And make sure that if you can't do that division in your head, and I don't expect you to, but if you can't do that in your head, show your work over here on your scratch section. Remember, when you divide signed numbers, it says if you're dividing the absolute values of them as if you're dividing by positive and negative. I mean by just positives, but we're actually dividing by -4, so we have to have that out there. But we just say, how many times does 4 go into 6? 1 times 4, 28. 4 times 7 is 28. How do we know if this quotient is a positive or a negative? The way we know if the quotient, which is the solution here to a division problem, is positive or negative, is you look at the signs of these two numbers here. The sign of the dividend and the sign of the divisor. When they are opposite signs, the quotient is negative. Negative 17. Now, they want us to go ahead and check, and that will allow us to verify that we actually know what we're talking about. Is it true that -4 times a -17 is equal to 78? Is that product really equal to did I say -78? Is it true that that product is equal to a positive 68? Well, what's 4 times 17? 4 sevens are 28, carry 2, 4 and 2, 68. So we have 68. We're multiplying integers. That means they have signs in front of them, positive or negative numbers. What happens when you multiply two negatives together? They have their little train wreck here. Two negatives, the product of two negative numbers is always positive. So yes, we have solved our division problem correctly. That's really all that's involved. Nothing new as far as how you do things. What you have to remember is my quotient going to be positive or negative? Is my product going to be positive or negative? Remember, product is multiplication. If the signs of the factors are the same, the factors are what you multiply together, the product is the answer. If those factors are the same, whether they're both positive or they're both negative, your product is going to be positive. With your quotient, if the numbers that you're dividing have opposite signs, the answer is negative. If the numbers that you're dividing have the same sign, regardless of if that sign is positive or if that sign is negative, if the signs are the same, the answer is going to be positive. So let's do another example from your book. Solve and check n divided by -3 is equal to a -15. N over -3 is equal to a -15. What's been done to the variable here on this side? Well, we started off with n, and then we divided by a negative number. Okay, in order to undo division, the inverse operation for that is multiplication. So if we've divided by -3, you also have to multiply, turn around now and multiply by a -3. You have to keep the sign the same. So you have -15 times a -3. We want to multiply both sides of that equation by a -3 because you have to keep your seesaw in balance here. So whatever you do to one side of the equation, you go ahead and do to the other side of the equation as well. We have the same factors here, same number in the numerator as we do in the denominator. -3 divided by -3 is a 1. You have n is equal to 3 times 15 is 45. 3 times 5 is 15. Carry 1. 3 and 1 is 4. Now, we've multiplied together their absolute values. We came up with 45. It's an integer problem. Sign numbers. Is that going to be negative or is it going to be positive? We're multiplying together two negative numbers. Multiply together two negative numbers. You've got a train wreck, it's always positive. So according to our solution and what we remember of the rules, our answer should be positive. Is that really true? Let's go ahead and check and see. Is it true that 45 divided by a negative 3 is really equal to a negative 15? Well, what's our rule? Our rule says that when you divide a positive number by a negative number, the signs are opposite, that answer is going to be a negative. 45 divided by 3, of course, is 15. 1 times 3 is 3. You subtract, you bring down the 5. 5 times 3 is 15. Negative 15 is in fact equal to negative 15. That's all you're doing with section 4.7. That's the end of our teaching for today. I want to remind you that when you come back to class next week, which will be Friday, November the 9th, make sure that you bring all of your homework. The homework that you would have turned in class today, November 2nd, which is section 4.1 through 4.4. This homework that is due that we covered in class today, that would be section 4.5, 4.6, 4.7, as well as the review. And you also have your chapter 4 test. You're not in class now, so I'm not handing you that test. What you have to do is you go to the ARC website, download that test from your pre-algebra class page, and bring that back to class also on November 9th. Also remember that we have a voluntary help class scheduled. It's optional. It's Monday, November 5th, scheduled from 9 to 10:15. I'll answer any questions you have. I'll give you, we'll do some of the problems like what you'll be doing on your test. I do ask that you shoot me a text and let me know if you're planning on attending. There's no cost, but you do have to get out to my house and let me know. So y'all have a great weekend. I'll see you live and in person next week.